All right, welcome back to the channel. This is going to be the second part of reading through the Java Programming Introduction book. So, um, I'm Eric Jordan. Please like and subscribe if you have seen any other video and you like my content. So, we're trying to get through this book. Right, we stopped off on logic errors. Um, I'm trying a new camera angle, so work with me. Fairly new to YouTube. So, 1.10.3 Logic errors. Logic errors occur when a program does not perform the way it was intended. Errors of this kind occur for many different reasons. For example, suppose you write the program enlisting 1.6 to convert Celsius 35 degrees to Fahrenheit. Listing 1.6 show logic. That's just the title. Public class named show logic errors. So this is the main method, and inside of it we have system.out print. So on this statement line, we're gonna print Celsius 35 is Fahrenheit degree. We have the terminator declaration, and then on this one, system.out.print line, and then this expression. So as we continue reading, I think some of the parts I'm not gonna read every character for the name. I think it gets redundant at some point. So I think it's good practice, but yeah. So Celsius 35 is Fahrenheit degree 67, um, which is both of these print statements together. One's this might actually I would try this out because I think this technically would be on a new line, but neither here or there. You will get Fahrenheit 67 degrees, which is wrong. It should be 95. In Java, the division for integers is the quotient. The fractional part is truncated. So in Java, 9 divided by 5 is 1. To get this correct, you need to use 9.0, which is a float, and divided by 5, which results in 1.8, which is also a float. We'll get into floats, sure, syntactically later in the book. In general, syntax errors are easy to find and easy to correct because the compiler gives indications as to where the errors came from and why they are wrong. Runtime errors are not difficult to find, either since the reasons and locations for the errors are displayed on the console when the program aborts. Finding logic errors, on the other hand, can be very challenging. In the upcoming chapters, you will learn techniques of tracing programs and finding the logic errors. At, so this next section is common errors. Missing a closing brace, missing a semicolon, missing quotation marks for strings, misspelling names are common errors for new programmers. Common error 1, missing braces. The braces are used to denote a block in the program. Each opening brace must be matched by a closing brace. A common error is missing the closing brace. To avoid this error, type a closing brace whenever an opening brace is typed, as shown in the following example. Right here, we have the class with the name of welcome. We have the opening brace and then the closing brace. Type the closing brace right away to match the opening brace. If you use an IDE such as NetBeans and Eclipse, the IDE will automatically insert a closing brace for the opening brace typed. Common error number 2, missing semicolons, um, which is the terminator declaration. Each statement ends with this statement terminator, which was the semicolon. Often, a new programmer forgets to place a statement terminator for the last statement in the block, as shown in the following example. Public static void, so the main method with 3 print statements. One that says program is fun, the next statement says fundamentals first, and then the next one says problem driven. They point out that this one is actually missing a semicolon. We can see that the other two do have the semicolon and they have the open and closed brace for this main method. Common error 3, missing quotation marks. A string must be placed inside the quotation marks. Often, a new programmer forgets to place a quotation mark at the end of a string, as shown in the following example. Here's a print line, problem statement. So this has the quotation marks, but this one does not. And so you have two in in this print line. It should be two, but since it's missing it, if you use an IDE such as NetBeans and Eclipse, the IDE will automatically insert a closing quotation mark for each opening quotation mark typed. Common error number 4, misspelling names. Java is case sensitive. Misspelling names is a common error for new programmers. For example, the word main is misspelled as main with a capital M, and string is misspelled as string in the following code with the lowercase s. Public class named test. In this class, we have this main method, and inside of there, we have a print line with this expression and the closing statement. Oh, so it's right, the main part and then the string. So should be flipped capitalization wise. As we see, it should be lowercase m in main, and then it should be a higher case s in string. So what are the errors, compile errors, runtime errors, and logic errors? So compile errors, the I like to just go back to the definition and not just interject what I believe it is, because it's pretty black and white on this. Um, sort of reading through. I actually need my glasses, but been able to find them. Um, I have forgotten the point. Oh, syntax errors. What are syntax errors? Syntax errors are should be this next section. I actually have it italicized. So I must have skipped over it. Here. Errors that are detected by a compiler are called the syntax errors. So they're errors that the compiler detects, or compile errors. Syntax errors result from errors in code construction, such as mistyping the keywords. So it was the first example that we did where the M was the wrong case, and so in main, and then the S was the wrong case in string. Close and brace. These errors are usually easy to detect because the compiler tells you where they are and what caused them. All right, so you'll look in the compiler, most likely it'll be a console, and it'll tell you, um, because this is on a Windows computer, it looks a little bit different as we saw in the first video. But let's go to the next question. I think we get the point. Given examples of syntax errors, runtime errors, and logic errors, I think we just went over those two. Logic errors is when you get an unexpected result, but that's probably not detailed enough, so we'll go back. They occur when the program does not perform the way it was intended. Errors of this kind occur for many different reasons. For example, suppose you wrote the program and it was this program they gave, and you wrote 35 degrees to Fahrenheit. So in this one, the main and string are correct. However, because of the values of these expressions, and they're not initialized, so they're not set to be a certain data type, then it kind of defaults into the wrong data type, not giving you accurate enough details in order to get to the answer that you are looking for. That I guess another human being would be looking for in data. Um, I think I skipped over where I was supposed to go. Oh, so okay, I probably should explain. I have the belief, like these checkpoint questions are they're annoying, but I feel like they're detrimental. Not detrimental. I feel like they're essential for learning the material. And for me, it's like that in like all my college courses because they'll give you things and they'll just suggest, but like somebody took the time out to write that, and it might help you better understand the concept. So that's why I take the time out to do these little exercises. It's going to take us longer to get through the book, but really the idea is the meaning behind the text, right? And then uh, those checkpoints want to make sure that you have the I guess mindset and the knowledge to move forward, right? As you can see, even though I just read things, I don't retain all that well, so they go back and forth, back and forth, back and forth. But if you're watching, hopefully it helps you. And let's continue. If you forget to put a closing quotation mark on a string, sorry, I had to make sure I was recording. If you forget to put a closing quotation mark on a string, what kind of error will be raised? Oh, I forget what it'll say because it just says it'll fix it. So I still have Eclipse open. So let's find out. I guess I could have just took it off Hello World. It's kind of the same thing. And we're going to say, always say resource. Okay, so it says exception in the thread main Java Lang dot error unresolved compilation problem. String literal is not properly closed by double quote. So this, I guess, is considered a string literal. And inside of this string literal is not properly closed by that double quote. Quick fix, answer missing quote. So it'll do it for you, but it definitely did it wrong because it put the quote on the outside of the statement. I'm just curious what'll happen if I put another parentheses on top of that, and if I'm assuming it would actually still run, and then it would just have the parentheses and that on there, and ignore, yeah, and ignore the not ignore, but include the parentheses before the quotation marks. That's hard for another human to read, but I guess for a compiler, it is fine. Need, if your program needs to read integers, but the user intended strings, an error would occur when running this program. What kind of error is it? This is a logic error because your program needs to read strings, but the user read integers, but the user enters strings. So you would need some kind of way to convert from one data type to the next. So you would probably end up creating a method or using one that's inside of a class or inside of a library to get to where you need to be with the data, to get it to read properly from the input. Suppose you write a program for computing the perimeter of a rectangle, and you mistakenly write your program so it computes the area of a rectangle. What kind of error is this? I'm just gonna say it is a logic error again, um, because everything probably will run, but you won't get the right outcome. Identify and fix the errors in the following code. We got a class called welcome. We got a main. We got an open and close main bracket for this main method. And then we have a class. Oh, nope, got a parentheses right there. So we get an error. What would it say? I'm actually not sure. Um, but let's find out. Run that. Exception in the thread. Main java.lang.error unresolved compilation problem. At intro to one dot welcome dot main welcome dot java 4. So it just gives you the class and tells you unresolved compilation. So a runtime error, I guess. It's technically syntax too, kind of both, because you're not following the rules for Java. All right, so Section 1.8 introduced developing programs for the command line. Many of our readers also use an IDE. The following two sections introduce two most popular Java IDEs, that means in Eclipse. These two sections might be skipped. So I already have Eclipse installed on my computer. So as far as installation of a program, I think you can do it. That's all I'm gonna say about that. So it just shows you how to create the project, how to find the file for the project, and how to label it inside the this is showing you inside of NetBeans how to set up a project and the locations to get going. So I'm not using NetBeans. It's not pointless. I mean, it's almost virtually the same as Eclipse. I'm just trying to skip through the Eclipse bit by it's kind of reading through. There were a lot of keywords here. Some things I kind of know what they do from other, experiences, but I don't know the actual technical name, so bear with me. So this is a summary. I won't go over that, not yet. Maybe there is a quiz inside the book, but it's Pearson, and I'm paying for my book, so I'm assuming you would pay to test yourself. If you're going that serious into it, we cannot stress enough the importance of learning programming through exercises. For this reason, this book provides a large number of programming exercises at various levels of difficulty. The program covers many application areas: math, science, business, financial, gaming, animation, and multimedia. Solutions to most even number programming exercises are on companion website. Solutions to most odd numbered programming exercises are on the instructor resource website. The level of difficulty is rated easy, no star, moderate, hard, or challenging. So here's some exercises. Display three messages. They did that already. Display five. Display a pattern. That one's a little bit more of a difficult one. I'm assuming they mean this is inside of Pearson. You can print a table. Display results. Formulas. All right, we're gonna skip all that. I mean, that's stuff that you should know, right? You want to know. I mean, you even have AI, right? I mean, you could ask AI to give you an example, and if you want to go further into that, but we're gonna skip those and get back to reading the book. These are just the objectives. I'm going to see if I agree with some of the objectives. You know what I'm trying to say. Why is that word so hard for me to say? So, elementary. I'm not running off coffee today, so I'm gonna say that. So thank you if you've made it to this point. You're 20 minutes in. Thank you. Uh, objectives: to write Java programs to perform simple computations, to obtain input from the console using the scanner class. Almost wanted to do the Birdman hand rub right there because now we're getting into the inputs. To use identifiers to name variables, constants, methods, and classes. To use variables to store data. To program with assignment statements and assignment expressions. To use constants to store permanent data. To name classes, methods, variables, and constants by following their naming conventions. To explore Java numeric primitive data types such as byte, short, ints, longs, floats, and doubles. To read a byte, short, int, long, float, or double value from the keyboard. To perform operations using one of those expressions that you see here. To perform exponent operations using math.pow with uh, these parameters. To write integer literals, floating point literals, and literals in specific scientific notation. To write and evaluate numeric expressions. To obtain the current system time using system.current-time methods. That's actually pretty important. I mean, they're all important, but um, let's just say it will come up if you're in school. To use augmented assignment operators to distinguish between post-increment and pre-increment and between post-decrement and pre-decrement, to cast the value of one type to another type, to describe software development process and apply it to develop a loan payment program. That will come up. To write programs that converts a large amount of money into smaller units. To avoid common errors and pitfalls in elementary programming. All right, so we are going to continue. I'm going to pause it for a second and drink some water. All right, so we read on the first video that we really wanted to see if we could skip to 55. We didn't. It is what it is. It's for education. Introduction. The focus of this chapter is on learning elementary programming techniques to solve problems. In Chapter 1, you learn how to create and compile and run very basic Java programs. You will learn how to solve problems by writing programs. Through these problems, you will learn elementary programming using primitive data types, variables, constants, operators, expressions, and input and output. Suppose, for example, you need to take out a student loan. Given the loan amount, the long term, the annual interest rate, can you write a program to compute the monthly payment and total payment? This chapter shows you how to write a program like this. Along the way, you will learn the basic steps into analyzing a problem, designing a solution, and implementing the solution by creating a program. So, this is where learning this is useful. I'm going to go throughout the book and see how they teach it, but I will show this and I will link it as well a little further up. So, if you do um, edX and go to the course for systematic program design, how to design functions. I find it so useful um, because you go through this methodology for steps and how to design um, functions. And oftentimes, I feel like that's where a little bit of the logic is kind of lost because they kind of just tell you, do this, do this, do this, do this. So somewhere along in this series, I might do a separate series just for the how to design functions part. I don't own this website. It's for education purposes. This class is free. Um, Meaning systematic program design. So that was a wordful, a mouthful. We're going to get back to the book. Introduction. The focus of this chapter is learning. I think I already read that. Right. Writing a simple program. Writing a program involves designing a strategy for solving the problem, then using a programming language to implement that strategy. Let's consider the simple problem of computing the area of a circle. How do we write a program for solving this problem? Writing a program involves designing algorithms and translating algorithms into programming instructions or code. An algorithm lists the steps you can follow to solve a problem. Algorithms can help programmers plan a program before writing it. In programming language, algorithms can be described in natural language or pseudocode. Natural language mixed with some programming code, the algorithm for calculating the area of a circle can be described as follows. Read in the circle's radius. Compute the area using the following formula. Area equals radius times pi. Display the result. So we have the problem, the algorithm, and the pseudocode. It's always a good practice to outline your program or its underlying problem in the form of an algorithm before you begin coding. When you code, that is, when you write a program, you translate an algorithm into a program. You already know every Java program begins with a class definition in which the keyword class is followed by the class name. Assume you have chosen compute area as the class name. The outline of the program will look as follows. We have a public class with the name of the class being compute area, details to be given later, comment, and then we have the end of the class, the closing brace. As you know, every Java program must have a main method where program execution begins. The program is then expanded as follows. Public class, compute area, and then we have the main method, And inside of that main, we have two comments that are describing the algorithm for what you're going to program. In step one, we're going to read the radius. Then in step two, we're going to compute the area. In step three, we're going to display the area, and then we have the closing braces. The program needs to read the radius entered by the user from the keyboard. This raises two important issues: reading the radius, storing the radius in the program. Let's address the second issue first. In order to store the radius, the program needs to declare a symbol called a variable. A variable represents a value stored in the computer's memory. Rather than using X and Y as variable names, choose descriptive names. In this case, the radius for radius and area for area to let the compiler know what radius and area are. Specify the data types, that is, the kind of data stored in a variable, whether an integer, real number, or something else. This is known as declaration variables. Java provides simple data types for representing integers, real numbers, characters, and Boolean types. These types are known as primitive data types or fundamental types. Real numbers, numbers with a decimal point, are represented using a method known as floating point in computers. Therefore, the real numbers are also called floating point numbers. In Java, you can use the keyword double to declare a floating point variable, declare radius, area as doubles. The program can be expanded as follows. Public class with the name of compute area. We have a main method. We have a double with radius. We have a double with area. So these are the primitive data types, and the one that we are using to declare these variables of radius and area are the primitive data types double. And so double, you're declaring a floating point variable. So that's the name of the variable. That's the name of the declaration. The keyword double to declare a floating point variable. So in step one, we're going to read the radius. Step two, we're going to compute the area. Step three, we're going to display the area. So, I mean, it sounds like, the steps that you do in real life were broken down into a recipe. You're going to read the words on the paper. You're going to figure out the math for it, write the formula, and then, in this case, instead of you doing it by hand, the computer does it with you putting the right expressions into the right syntax for the compiler to understand, and then it's going to display it in the area. It's going to output it. It could be a console. It could be whatever interface that you set up your program to run on. The program declares radius and area as a variable. The reserved variable indicates the radius and area of floating point value stored in the computer. The first step is to prompt the user to designate the circle radius. You will soon learn how to prompt the user for information. For now, learn how variables work. You can assign a fixed value to radius in the program as you write the code. Later, you'll modify the program to prompt the user for the value. The second step is to compute area by assigning the result of the expression radius times pi to area. In the final step, the program will display the value of area on the console by using the system.out.println method. Listing 2.1 shows the complete program, and a sample run of the program is shown in figure 2.1. 2.1 compute area.java. Here's the public class with the name of compute area. Then we have this main method with the keyword um, print of data type double, and the variable. And so we're going to declare radius as a double and area as a double. We're going to assign a radius. So in this case, we're going to assign radius equals 20. So radius is now equals 20 inside of the compiler. And, well, I mean, inside of the program. And technically, the compiler, when it runs, and compute the area. Area equals radius times pi. We're going to display the results. System.out print line. The area of the circle of a radius plus radius is plus area. It shows you how it's going to compile on a local level. The program displays the area of a circle. Variables such as radius and area correspond to memory locations. Should we write this out? Even if we wrote this out, my thing is radius is 20, but area is double, and we didn't declare anything yet. So I'll just keep reading. I'm sure we get to that point. One moment. Looking at the time, 6 minutes in. Not sure how long I'm gonna be able to go on this one, guys. I'm not gonna lie. We try to hang in there. Variables such as a radius and an area correspond to memory locations. Every variable has a name, a type, and a value. Line 3 declares that the radius can store a double value. The value is not defined until you assign a value. Line 7 assigns 20 into the variable radius. Similarly, 4 declares the variable area, and line 10 assigns a value into area. The following table shows the value in the memory for area and radius as the program is executed. Each row in the table shows the value of variables after the statement, and the corresponding line in the program is executed. This method of reviewing how a program works is called tracing a program. Tracing programs are helpful for understanding how programs work, and they are useful tools for finding errors in a program. So, sorry, make sure I didn't lose something here. Reading back through. All right, so line 3, there's no value for radius. And line 4, there's no value for area. Line 7, we declared a double of the value of 20 for radius. And then line 10, it says 1256.636. Didn't see that up top, but I'm sure we're getting to that. The plus sign, plus, has two meanings. One for addition and the other for concatenation and combining strings. The plus sign plus in lines 13 through 14 is called the string concatenation operator and combines two strings into one. If a string is combined with a number, the number is converted into a string and concatenated with the other string. Therefore, the plus sign plus in lines 13 through 14 concatenation strings into a longer string, which is displayed in output. Strings and string concatenations will be discussed further in chapter 4. Okay, so I'm gonna pause. Gotta let my dog out, and I'll be back. All right, continuing. So a string cannot cross lines in the source code. Thus, the following statement would result in a compile error. So we have a print line statement, and it says Introduction to Java Programming by Daniel Liang. And to fix the error, break the string into separate substrings and use the concatenation operator plus to combine them. So we're breaking this into two strings and then using the plus. It says the string cannot cross lines. I'm not sure what it means by that. I'm not sure what it means by that completely. Oh, it doesn't have quotations, but it has a bunch of spaces. If, I'm kind of confused by this. Oh, because it's on literally the next line, then you get an error. Did not. So it kind of works like the comment. Um, so you have to concatenate with the plus, turn this both into strings. I'm not sure if it's given space. But the next time we run it, it at least runs. I mean, it doesn't have a new line in our line break, which is /n. Uh, the print line automatically prints on the new line after the next printed word. So, yeah, we learned something new today. Did not know that. Um, wonder if I've accidentally broken something. And once we get through like enough stuff, and I've kind of reviewed and went back and learned enough to be dangerous, I should. I don't know about vibe coding though, right? So you should just build a website or something, build an app, build a SaaS app or something, and see what we can do. Let's put our minds to it. All right, so let's continue. Identify and fix the errors in the following code. We got a public class named test, and then we have the main void. Inside of there, we have these three variables, I, k, and j. They are all keyworded with the parental data type of double. The value of I is 50. The value of k, oh, wait, the value of k equals I plus 50. It's a little different, right? And then we got double equals j. I'm sorry, double j equals k plus 1 with the terminator. I'm just saying terminator because it sounds cool. And then we have print line. J is plus j plus, got some open quotes here, k is plus k. So the errors that are going to occur, I think, is some kind of data type. It's not initialized. Because all we have is I. We don't have k. We don't have j. Um, they have no values. They just have kind of expressions inside of them. Um, and yeah, there's no following methods that declares what they are. There's no constants. I'm getting like super advanced in some of these terms, so I apologize, but meaning there's nothing pointing to these variables and giving them anything outside of the primitive data type for values. Nothing's giving them values. Reading input from the console. Reading input from the console enables the program to accept input from the user. In listing 2.1, the radius is fixed in the source code. To use a different radius, you have to modify the source code or recompile it. Obviously, this is not convenient. So instead, you can use the scanner class for the console input. Java uses system.out to refer to the standard output device, and system.in as the standard input device. By default, the output device is the display monitor, and the input device is the keyboard. To perform console output, you simply use the println method to display a primitive value or string to the console. To perform a console input, you need to use the scanner class to create a new object to read input from the system.in as follows. We have scanner input equals new scanner with system.in. The syntax new scanner system in creates an object of scanner type. So earlier we had variables being declared with primitive data types. In this case, we have objects being declared with the scanner data type. The syntax scanner input declares the input is a variable whose type is scanner. So input is the variable, right? Like we said before, with uh, the variable type data scanner. The whole line reference to the variable input, an object may invoke its methods. To invoke a method on an object is to ask the object to perform a task. You can invoke the next double method to read a double value as follows. So I apologize. To put the what I'm reading in context and then make sure that I understand it to convey it properly. Um, I'm going to take a second and pause, reread this. Actually, let's read the whole thing and let's go from there. Double radius equals input dot next double. This statement reads the number from the keyboard and assigns the number to radius. So it has a variable with a primitive data type, but it equals the input of the next double that is written in keyboard. Listing 2.2 rewrites listing 2.1 prompt the user to enter a radius. So I'm going to briefly reread this real quick. I guess it was the statement to invoke a method on an object is to ask the object to perform a task. You can invoke the next double method to read a double value as follows. I guess it's just how they blatantly put it. It could be a little jarring. Import uh, compute area with console input.java. Import java.util.scanner. Scanner is the Java util.package import class. So now it's teaching us about imports. So we're going to put this import package, which I'm sure they're going to explain further. So I'll keep reading through. We have a public class with the name of compute area with console input. Then we have the main method. We have some instructions here. So part of the algorithm is to create a scanner object. We have the scanner input. We have the scanner data type with the input um, as the variable name, and it's going to equal new scanner system.in. So a keyboard object, so an object of scanner with the input of the keyboard. And then we're going to prompt the user to enter radius, system.out print, enter a number for radius, double radius, equals input dot next double, and compute area is the next um, algorithm, double area. So a new variable for the area, which is radius times pi. And we're going to output the print line, the area of the circle of the radius in quotations plus radius is, sorry, plus radius plus quotation is, I'm trying to say, this string plus area with the term. Enter a number for the radius, 2.5. The area of the circle of a radius of 2.5 is 19.6349375. Enter a number of radius 23. So this is the prompts that is prompting the user on the keyboard, and we're going to try to see if we can get this to run. Hopefully it doesn't copy over these. Um, I'm trying to say. Hopefully it doesn't bring those in and think we're trying to do something else. Package intro. I think I gotta keep that first package. Don't want to cause any problems. Can I just paste? Ooh, I got all kinds of errors there. All kinds of errors. Probably because of the numbers up front. Alright. Yep. I'm not sure about the first error. We have to look that through. Okay, I'm not going to be able to copy the examples because I don't want to have to do this every time. It's going to be tedious stuff. Pretty sure there's probably a better way to copy. I don't know it. Point check. Where's it getting that from? Point check video note. Read a double, create a scanner. I don't know where it's getting that from. So we got radius is plus area at the bottom. Take this number out. Take that out because we already have our open and closed braces. And why do we have an error here? Rename a compilation unit welcome.java. Because the original class name is welcome.java. So I'm just going to hit welcome and see if it'll let us at least compute. I changed the class name, but it should still do what I'm supposed to do. So I apologize about changing the class name. 2.5. I don't want to rename the file. Uh, so we do have the same output when we enter a program. I think I have to run it again, right? And then this time I'm going to do 23, and we have the same output. So it's working for the console input. Let's just put it like that. I'm trying to find the right ways to phrase some of this stuff. Anyway, so we're gonna see if we can muscle through. I think we're already on about an hour. I'm trying to get through maybe this next input, and then we're going to pause it. Potentially, I don't know. I might come back I might come back and just do a part three. Uh, I don't know how many parts of this series we're gonna have, but anyway, let's get back to it. The scanner class is the java.util package is imported in line 1. Line 6 creates a scanner object. Note the import statement can be omitted if you replace scanner by java util.scanner in line 6. So it's saying here, if you place the whole name java.util.scanner for scanner, then you don't have to put the import in because it knows where to find that package for reference of a, I guess, of a type for your variable. Maybe I'm wrong on the way that I phrased that, but in my mind, that's how it works so far. So apologies if any confusion is happening. Line 9 displays enter a number for radius to the console. This is known as a prompt because it directs the user to enter an input. Your program should always tell the user to enter when it's expected input from the keyboard. Recall that the print method in line 9 is identical to the print line method, except the print line moves at the beginning of the next line after displaying the string, but print does not advance the next line when compiled. So they're just talking about here, instead of print line, they just use print. So it's going to show up on the same line as this next statement. Uh, and we think we did see it here. The area of a circle, notice that the area of a circle, enter name for the radius, the area of a circle of radius, it's all combined. No, I'm lying. We got the input, just print. That's just all on the same line. So really, if you did line, it would make less sense here because then I believe the input for the keyboard would be below it, and humans reading that and having to go to the next line. I think that just annoys us. I don't know what part of UI science that is, but no one wants to go to the next line to read that. Um, yeah, right. So backend guy designed the front end, most likely. So they anyway, I digress. Recall the print method in line 9 is identical to the print line method, except for print line. We already read that, sorry. So we are here. Line 6 creates a scanner object. This statement in line 10 reads the input from the keyboard. Double radius equals input dot next double. After the user enters a number and presses the enter key, the program reads the number and assigns it to the radius. More details on objects will be introduced in Chapter 9. We early reading said something was going to be introduced in Chapter 4. Um, I'm just saying, so it might take a while to get back to some of the references. For the time, simply accept this is how we obtain input from the console. The scanner class is in java.util package. It is imported in line 1. There are two types, import statements, specific import and wildcard import. The specific import specifies a single class in the import statement. For example, the following statement, scanner from the package java.util. Import java.util.scanner, and then we have the wildcard import, which is it imports all the classes in the package by using the asterisk as the wildcard. For example, the following statement imports all the classes from the package. Import java.util.asterisk with the terminator. The information for the class is imported packages not read in a compile time or runtime unless the class is used in the program. The import statement simply tells the compiler where to locate the classes. There is no performance difference between a specific import and a wildcard import declaration. That's actually good to know, right? Because I'm thinking, oh, it imports all of the uh, packages and imports all the classes from that package. So wouldn't that be more data? But here, uh, it makes sure that it specify that that's not how that works, even though um, the author knew that we might draw that conclusion. Listing 2.3 gives an example of reading multiple inputs from the keyboard. The program reads three numbers and displays their average. We have an import java.util scanner. So the algorithm says this is the scanner is in the Java util package, right? Because we know we're going to be accessing it in order to get input. Public class named compute average. And there's a main method. And in this main method, we're going to create a scanner object from that comment. And then the scanner input equals new. We don't have to do the full thing since we have the import here. We have a new scanner object with system.in for the parameter, which is a keyboard input, and inside of this object. So I don't think they really explain new. Hopefully they do that, explain what this is. For now, just know this is how you write it. Prompt the user to enter three numbers. System.out.print, enter three numbers. So we have the three variables here. They're all labeled with the parameter double, and they all accept input dot next double. Um, so I'm assuming this just means keyboard read, keyboard read, keyboard read. Double average equals number one plus number two plus number three divided by three. So we are doing the average um, formula, and we're going to display results. The average of number one plus number two plus number three is average. Enter the three numbers 1, 2, 3, 1.0, average of 1.0, 2.0, 3.0 is 2.0. It's so weird how they have that displayed. And enter three numbers 10.5 and 11 and 11.5. So these are the three inputs for the variables that it's looking for a double, which is a decimal number. And the codes for importing the scanner class line 1 and creating a scanner object line 6 are the same as the preceding example. As well as in all new programs, you will write for reading input from the keyboard. Line 9 prompts the user to enter three numbers. The numbers are read in lines 10 through 12. You may enter three numbers separated by spaces, then press enter, or each number followed by the enter on the keyboard as shown as the sample runs this program. If you entered an input other than a numeric value, a runtime error would occur. In Chapter 12, you will learn to handle the exceptions to the program so it can actually continue to run. Most programs in early chapters of the book perform through steps, input, process, and output, called IPO. An input is receiving input from the user, process is producing results using the input, and output is displaying the results. If you use an IDE such as Eclipse or NetBeans, you will get a warning to ask you to close the input for preventing a potential resource leak. Ignore the warning for the time being because the input is automatically closed when your program is terminated. In this case, There will be no resource leaking. How do you write a statement to let the user enter a double value from the keyboard? What happens if you enter 5A when you're executing the code? So I think we're gonna maybe stop there. It's gonna take some time to answer these questions. So I mean, they just showed us an example, so I won't do it. I mean, but you need to import java.util scanner package. Then you need this. You need scanner input equals new scanner system in um, to create a scanner object, and then you're going to create variables to hold the input of the from the scanner object, and you're going to store it into a variable, and then you're going to compute it in some way and display it in some way with a print statement. So the next one is, are there any performance differences to the following inputs? The answer is no. I talked about that. 2.4 identifiers. Identifiers are names that identify the elements such as classes, methods, and variables in a program. As you see in listing 2.3, compute average, main, input, number one, number two, number three, and so on are the names of things that appear in the program. In program terminology, such names are called identifiers. All identifiers must obey the following rules. As an identifier is a sequence of characters that consist of letters, digits, underscores, and dollar signs. An identifier must start with a letter, an underscore, or a dollar sign. It cannot start with a digit. So that's a letter, an underscore, or a dollar sign. It cannot start with a digit. uh, Probably get a syntax error, and or maybe some kind of compile error, or you know what I'm trying to say. You'll get an error. An identifier cannot be reserved and a reserved word. Appendix A for a list of reserved words. So we kind of went over reserved words in the first part, but there's some things that mean have specific meaning in the system specific syntax in Java, so you can't use them. Otherwise, it'll give an error. I An identifier cannot be true, false, or null. An identifier can be of any length. For example, dollar sign two, computer area, radius, and print are legal identifiers, whereas 2A and D4 are not because they do not follow the same rules, and the Java compiler detects illegal identifiers and reports the syntax errors because this one has the number, the D plus 4 identifier must start with a letter, it cannot start with a digit, and it can only consist of letters, digits, underscores, and dollar signs. Plus is the operator for Java, so you will get illegal identifiers reports, and yes, it would be a syntax error. So since Java is case sensitive, area is different from the capital area with a lowercase is different from the capital area with a higher case A, or if it's all caps, that's all different identifiers. Identifiers for naming variables, methods, classes, and other items in a program, descriptive identifiers make programs easy to read. Avoid using abbreviations for identifiers. Using complete words is more descriptive. For an example, number of students is better than num studs, num of studs, or num of students. We use descriptive names for complete programs in the next text. However, we will occasionally use a variable names as such as I, J, K, X, and Y in the code snippets for brevity. These names also provide a generic tone to the code snippets. So this comes from, I don't know if you've read Code Complete or Clean Code is an idea that the variable names, like they're saying, should be very descriptive as possible because it prevents you from making errors inside your logic with your methods because um, you know what that variable does when you come back to it. Hopefully, you have the right comments, and then you also have the right variable names, and then you also have um, names that aren't weird for your methods to fix whatever you're writing. I think a large problem when I mean I don't read a lot of legacy code, but I used to kind of. So and I've always been involved where large organizations are switching from one program to the next program or the next system, I should say, and there's all kinds of problems. There's all kinds of problems because the legacy code it can say one thing and do another, and then the new system maybe all the design factors weren't cued in. Maybe there's not enough time. Maybe there's a long sprint to to get updates on the system, and therefore it takes forever. Um, and so in the meantime, there's all these. They usually have some method of creating a case with either the support team or directly to developers or both, and then you kind of work through the the nature of the problem and try to get a solution for it, and you got to write it all out and work with a bunch of groups to get things fixed. That's normally how this goes. So that being said, um, read clean code. All right. I probably need to reread it. I've read it. I've read it enough. I want to say 3 or 4 times. I feel like I'll read it every year, but I guess every few years. Do not name identifiers with the dollar sign character. By convention, the dollar sign character should be used only in the mechanically generated source code. Which of the following identifiers are valid? Which are Java keywords? Um, say miles valid, test, keyword A++, not valid, not valid. You get the idea, right? We just talked about it. I mean, these are keywords for Java. Keyword, valid, valid, and radius is a keyword. So valid, I guess, technically. Variables are used to represent values that may be changed in the program. As you see from the programs in the preceding sections, variables are used to store values to be used later in the program. They are called variables because their values can be changed. In the program listing 2.2, radius and area are variables of the double type. You can assign any numerical value to radius and area, and the values of radius and area can be reassigned. For example, in the following code, radius is initially 1.0 on line 2, then changed to 2.0 on line 7, and the area is set to pi on line 3, and then reset to 12.56636. So we see here it's computed first, and this is the algorithm for that. We got radius initialized to the value of 1.0, which I guess technically is a float. And then we have area equals radius times pi, which is the area is 3.14 because radius is 1. And then we have system print. So I guess we would print the area and the radius with that text in between. Then we got the second computation algorithm for radius is now equal to 2.0. So we see that. And then we have the same formula over again. And now it's 12.56636. And then we're outputting the area plus the radius again with the text around it. Variables are for representing data of certain type. To use a variable, you declare it by telling the compiler its name as well as what type of data it can store. The variable declaration tells the compiler to allocate appropriate memory space for the variable based on its data type. The syntax for declaring the variable is data type, variable name. So far, we've been saying that throughout at least chapter 2. Here are some examples of variable declarations. Integer count. So int count. Declare count to be an integer variable. Then we have a variable named radius with that's declared as a double variable. Then we have interest rate declared as a double variable. These examples use the data type int and double. Later, you will be introduced to additional data types such as byte, short, long, float, character, and boolean. Oh, fun. If variables are of the same type, they can be declared together as follows. Data type, variable 1, variable 2, and variable blend. The variables are separated by commas. For example, you can do int with I, comma, j, comma, k. You declared I, j, and k as int variables. Variables often have initial values. You can declare a variable and initialize it in one step. Initial variables consider, for instance, the following code. Here's the integer of a variable named count. I'm trying to make sure I said that right. Yep, equals uh, the value of 1. This is equivalent to the next two statements. Int count, count equals 1, right? And don't imagine print line or the line thing that we discovered later, because these are technically two different statements, but you can write it as one. You don't need two statements to equivalent the variable name of integer. You also found of the variable data type of integer. You can also use a shorthand form to declare and initialize variables of the same type together. For example, on the same line, you can do integer I equals 1, comma, j equals 2, but they're both integers, even though you have two different variable names with two different values, but on the same statement, they are all the same data type, integer. Tip: a variable must be declared before it can be assigned a value. A variable declared in a method must be assigned a value before it can be used. Whenever possible, declare a variable and assign its initial value in one step. This will make the program easy to read and avoid programming errors. So, I think this tip is actually valuable. A variable must be declared before it can be assigned a value. A variable declared in a method must be assigned a value before it can be used. That sounds simple. Just you can just read through that, but it's important. Um, we'll find out why later. I'll read this next line. Every variable has a scope. The scope of a variable is the part of the program where the variable can be referenced. The rules that define the scope of a variable will be gradually introduced later in this book. For now, all you need to know is the variable must be declared and initialized before it can be used. The scope is very important. I'm sure they're going to talk about it more later, but the larger the scope, the more likely you to have an error inside your program, um, because maybe created, you declare some values to those variables, and in your methods, maybe, okay, we're getting too far ahead of ourselves, but just know that that's important. How about that? I'm sure I'll talk about why it's important. I'm sure the author will talk about why it's important. You might even know why it's important already. So identify and fix errors in the following code. We got a public class named test with a main method where an integer I value is equal to k plus 2. Variable I is equal to k plus 2. And then we have a print. So we have an I that's a variable that's created as an integer, right? If it was just k, I don't think it would be a problem, but since it's k plus 2, there's no value to k. So the assignment designates the value, or assignment statements and assignment expressions. An assignment statement designates a value for a variable. An assignment statement can be used as an expression in Java. After a variable is declared, you can assign a value to it by using an assignment statement in Java. The equal sign is used as an assignment operator. The syntax for assignment statements is as follows. Variable equal sign, so assignment operator expression. An expression represents a computation involving values, variables, and operations that taking them together evaluates to a value. For example, consider the following code. I kind of just glossed over that, but I guess I was just a checkpoint. An expression represents a computation involving. So we got an integer y equals 1, double radius equals 1. We got the integer of x equals 5 times 3 divided by 2. And we got x is equal 1 plus y plus 1. Then we got a double area equals radius times pi to compute area. You can use a variable expression. A variable can be used in both sides of the operator, as we see. For example, x equals x plus 1. In the assignment statement, the result of x plus 1 is assigned to x. If x is 1 before the statement is executed, then it becomes 2 after the statement is executed. To assign a value to a variable, you must place the variable name to the left of the assignment operator. Thus, the following statement is wrong. 1 equals x is wrong because the variable name to the left of the assignment operator, not the right. In mathematics, x equals 2 times x plus 1 denotes an equation. However, in Java, x equals 2 times x plus 1 is an assignment statement that evaluates the expression 2 times x plus 1 and assigns the value to x. So it is not an equation, it is an assignment statement that evaluates the expression. In Java, an assignment statement is essentially an expression that evaluates to the value to be assigned to a variable on the left side. On the assignment operator, for this reason, an assignment statement is also known as an assignment expression. For example, the following code is correct. Okay, I think that's where I'm going to stop here. Page 65. Know that. All right, I noted that down. If you made it this far, thank you. Um, I have a ton of homework for next week, like a ton of it, for Java. So probably won't do this until the end of the week. I don't know how many times I'm gonna shoot these videos. Like I've been doing it kind of, I think they're now kind of days apart, but I'm not gonna have the time to do that. Um, I want to read through this regardless, but like recording and reading through it, and then going back and then doing homework and reading through, you know, chapters and chapters, and then yeah, and working on top of that. I don't know if I'll be able to. I'm not gonna lie to agree to do that, right? No one's asking for that, so that's what I'm saying. So I'm just doing this for all of us, right? So thank you. If you watched this far, you've enjoyed the content, please like and subscribe. Share the video. I'm trying to get used to this YouTube thing. I'm moving the camera around a little, and yeah, thank you for watching. Eric Jordan, peace out.